see here.
All right, this presentation is now being recorded.
Hello, gentlemen.
Good afternoon.
Hello, everyone.
Hello.
We've got about 35 people here now, and I know we've got about 3 times that sign up, so we'll just wait another minute or two before we get started and then people get connected.
At what point, Brad, do you think turning our video off and just joining the webinar by us participants will help the bandwidth?
It's not my bandwidth, Tom, so I'm not really concerned about it.
Okay.
Really just have
See a few more people who are joining and some others who are getting their audio connected, so I'll just give it a quick second here. Kind of playing by popcorn rules. As long as all the kernels keep popping, we'll keep it going, and once it starts to slow down, we'll pull the bag out.
Sounds good. We have the title slide visible to everyone at this point. I think you got
I
it.
see it.
I can see it.
Yep.
Oh, there we go.
Yeah, okay. Just keeping it on the title slide for the moment.
All right, we'll probably have a few more people joining us, but why don't we go ahead and get started? So let's start us off with a few. Ben, did you want to get us kicked off?
Sure. Hi, this is Ben Wallace with Minify Energy. Happy to host and bring together the first collaborative effort from the collaboration subcommittee or steering committee on BIG-TC, the Building Intelligence Group Twin Cities, in conjunction with AEE, Association of Energy Engineers. So we're excited to bring in this presentation on building intelligence around energy, and specifically focusing in on grid interactive energy efficient buildings. I want to take a minute, Brad, if you have anything you want to add from a welcome standpoint for Building Intelligence Group Twin Cities.
Sure, I can give a couple of quick big TC updates and a little bit of the housekeeping logistics.
Okay.
So thanks everybody for joining, and we're attempting to record today's meeting, so everybody behave. This is just a Zoom meeting, didn't set up as a webinar, so everybody is live on video and on audio. We take it as the honor system for people to be respectful and mute yourself when you are not talking. We have a chat room, so we'll use that for posting any of the running commentary and questions. I will try and call some of the questions from that chat room, and we'll try and get those answered during the Q&A towards the end of the presentation. And if possible, I will send out our recorded video link with the follow-up to this meeting. Building Intelligence Group, for those of you who have not participated before, and welcome to our friends from AEE and everybody else who's joining today. This group started a little over 2 years ago in response to there not being one local organization that could get all of us together to talk about the intelligent building. It's a conversation that was happening in fragments and subsections across our buildings industry, and we felt like, you know, we need to be bringing all these people together to have these conversations in one place and network and educate each other to help advance the adoption and the just general concepts around intelligent buildings. So that's how we got started, and we've been rolling with that ever since as a pretty informal grassroots group that meets wherever we can find some meeting space, and that we can just get together and provide content based on whatever the whole group decides is going to be helpful for all of us. We've been growing, so for over a year now, there's been a group down in Chicago that's led by Rory Barnwell from DLR Group that kind of seen what we did with this, said, you know, that's a pretty decent model, and it seems like it's been sustainable, so we'd like to just kind of piggyback on that, and we're glad that they did. They've been teaching us some of the things that they're doing that have worked well. We're sharing that information back with them, and we've had a lot of interest from other people around the country. Hey, is there a group like that in my town? Nope, probably not, but we're happy to give you guys some backup and support from what we've learned and let you go ahead and start one. So if anybody is interested in that, you can put your info in the chat and we'll get back to you about how you could be participating. So now there's about 10 different markets or so around the country, largely East Coast, Midwest, that are interested in springing up some of these groups. So now we have been looking at turning ourselves into a incorporated association. We have a committee that's set to help advise on what our terms of the incorporation should be, how do we want to be charging people for membership, and putting together a business plan, things like that. So we're actively recruiting for other people who are interested in trying to form what this thing should be as it goes forward and as it grows and supports not only our local chapters, but a more national offering. So if that's an interest to you, we're continuing to try and define what that ask is. Generally looks like 2 to 6 hours per month, and we've got a couple of different subcommittees that you could serve on. I don't want to take all of our time trying to go through that today, but if you have interest, I'd be happy to tell you more. Drop a line in the chat room on that as well. So questions in the chat. If you're interested in participating in organizing this group further in chat, and working on getting some meetings set up for the July-August timeframe. That's anticipated to be more virtual meetings. And one of the topics we're kicking around would be trying to set up a virtual tour of some of the world's smartest buildings. So last thing to put in chat, other than the general commentary, would be if there are any buildings you're interested in hearing more about, please let us know what that would be, and we'll try and find some connections so that we can get some speakers to talk about them and give us the virtual tour. With that, I want to turn it over to Peter Gephardt. Peter, do you want to introduce the AEE chapter?
Sure. Yeah, Brad said, Peter Gephardt with AEE. I am on the board. I think we have some other board members on this call as well. I did see Jill Ide, who is actually the president. I saw her name for sure. And I believe we have Paul Pagel from MinTap, and I don't know if Greg Shane made it on, but that's the board of our local Twin Cities chapter. We kind of are obviously an industry organization, industry group, centered around, energy sustainability education, models. So we do have quarterly events, are going to be virtual probably at this point for the rest of the year. And for those of you that don't know, never been to it, never heard of it, we do put on the Minnesota Energy Expo every September in collaboration with Minnesota ASHRAE. So that's going to be late September, virtual, probably half-day seminar this year. So watch the website for some updates on that as well.
Cool. Thanks, Peter. And this is Ben Wallace with Minify Energy. Myself and Dr. Lester Shen are co-chairs of the Collaboration Steering Committee on Big TC. And Peter's been working with us in the formulation and orchestration of pulling this presentation together. Unless there are any further intro or housekeeping issues, I'll move into introducing the panel and launching into the presentation. So appreciate you all making time to get together. We thought between Big TC and AEE, it was a nice melding of the organization's interest between intelligent buildings and energy engineering, where they meet in smart grid interactive energy efficient buildings. Got a panel presentation today. I'll be kicking off with kind of a framing up the marketplace for both smart buildings and the energy opportunity in the marketplace, and lead into the grid interactive building a little bit. Lester Shen from Center for Energy and Environment will pick up from that point. And then our key guest speakers are John Reinhardt, Demand Response Technology Lead at Great River Energy with the utility perspective, and Matt Schwartz, Director of Engineering from Parallel Technologies and integrator, kind of representing the integration and the corporate business perspective around grid interactive buildings. So we've got a lot of content for you pulled together today. Appreciate you guys submitting questions throughout via text, and if we exhaust those at the end, we'll also take audio, verbal questions and answers for discussion at the end. Unless anyone has anything further, I'll launch into the presentation. Quick introduction. My name is Ben Wallace. I'm co-founder of Minify Energy along with Jeremy Davis. We're a relatively new organization, started last year. We are focused on, really the goal is to minimize and simplify the process of reducing energy, and from a cost and consumption and carbon standpoint. So we're an energy efficiency implementation provider, doing everything from audits to lighting, HVAC, of course, smart building control solutions, water conservation, and renewables, as well as sustainability programs and guidance on that. We also very recently have been launching out a Minify Impact, which has a wider human wellness and safety and wellness factor. We're involved in some health and disaster response initiatives, particularly expanding from the energy interest into the indoor air quality health and wellness for internal environments, with some continuous disinfection, pathogen abatement solutions, everything from ventilation and humidity to ionization and UV light treatment, including far UVC, human safe lighting for the new normal as we return to office spaces moving forward. You'll see some reflection of the COVID impact in the content of the slides today. We're focused on energy, but always recognizing the importance of the human factors and wellness for the occupants. Just gonna frame up the smart building marketplace a little bit. Some of this might be old news for you guys, but just wanna identify a couple of resources and stats. Memori is a research organization, consulting firm that tracks the smart building marketplace. They have recently put out a new market prospects in the age of COVID-19 Q2 update to their projections for growth for building Internet of Things, BIoT market space. And as you can see, there was a pre-COVID growth trend, and then there's the best case and worst case scenario here that pretty much has dipped through 2021 and then returning to the pace of growth 2022 onward. But definitely lower numbers overall than originally projected. But thought that might be interesting for everyone to see some updated stats on projected growth for BIoT. They also have this subway metaphor presentation of building Internet of Things that considers, the different lines are, business, enterprise, user experience, security, energy, lighting, facilities, considers communications and so forth. We're going to be focusing in on the orange line here, which is really around energy, building energy management, ventilation, HVAC, lighting controls, and then down at the bottom is the key focus for our topic today, which is really, peak load shaving, demand response, and grid interactivity on that end. One other interesting note is new to this map is smart hygiene on the list, which I think we're going to see a lot more growth and efforts around in COVID, post-COVID era. Another interesting way to look at the growth of the market is where the startup segments exist for smart buildings. And this shows startups in 2019, the majority of them being in general BIoT platforms, but followed by building energy management applications. That said, I think this indoor mapping, location, and workplace management, space utilization are likely to grow at a higher rate, I would think, in the COVID and new normal for safe work environments as we're moving forward. So this presentation is meant to bring everyone up to speed. I think between AEE and Big TC, we've got a pretty knowledgeable audience, but bringing everyone up to the energy market opportunity, there's a lot of waste in buildings, in commercial buildings. Waste as much as 30 to 50% of energy. This Verdantix study shows, suggests that commercial buildings waste about 30% of the energy is wasted, equivalent of approximately 57 billion in market value. Likewise, the U.S. Department of Energy cites that commercial buildings use 40% of energy and 70% of electricity. And a little closer to home, there are projections from Minnesota's Energy Action Plan that suggest as much as 58% of total energy consumed in Minnesota is through inefficiencies. Now, that's not limited to buildings necessarily, but buildings make up a good chunk of that. And so between that, I think, paints the picture that there's a big opportunity in the market that we can do better and be more efficient, energy efficient, and smart building technologies can help us get there. There's also a gap, though, in that most buildings are not yet smart. These are slightly older numbers, but what you see on the right is 2003 and then 2012. In red, we're seeing large commercial buildings, which have a relatively high installed base of building automation, building intelligence solutions. The blue bar, which grew from 2003 to 2012, still in the single digits at that point, was for small commercial buildings. So I think everyone's probably aware that big Class A high-rises and large commercial buildings tend to get the systems out of the gate, but not necessarily the case for smaller buildings. The importance of this is accentuated by the fact that 98% of commercial buildings are small, under 100,000 square feet at least, and so there's a huge gap and opportunity in the marketplace, both in the waste of energy and the efficiency opportunities, and where smart building technologies can come in to address that. Also, a trend in the energy market is the trend toward net zero in many different factors, looking to try to get to zero carbon, or in this case, looking at buildings that consume as much or less energy than they create. So it tends to have energy generation on site, be it solar, wind, or hydro. Trying to balance out so that it's net consumption is zero carbon, or actually contributing net positive to the market. You can see on the left, New Buildings Institute is one organization concerned with net zero buildings, or ZNE, zero net energy buildings, and the hockey sticking growth chart there is also a publication, NZB buildings, if you're interested in looking into that further. One example of a net building or a zero net building is Walgreens in Evanston, Illinois. They launched this in 2013, and this happens to be just a dashboard that they have showing their geothermal, solar, and wind contributions relative to consumption, and just giving a dashboard to look at how things are going. So they're kind of proving out that you can have design and net zero building together with functionality. Also on the kind of net zero roadmap or vision trend is the Sustainable Buildings 2030 and B3 benchmarking here in Minnesota, which is used by for publicly funded programs and has a set of guidelines for focused on new buildings predominantly for codes and step codes and goals. And those are being revisited and updated. There's a session, four-part session that took place with some industry leaders to look at revisions to the codes and goals and step codes and look at how that trajectory can get us to the net zero goals for new building codes, but also in the B3 benchmarking, there are ways that existing buildings can factor into that too. All of this is, looking toward the 100% clean energy goal for Minnesota by 2050 that Governor Walz has put forward. Similarly, many other, net zero goals for 2030, 2040, 2050 set. Here's, in this instance, Minneapolis making the citywide goal by 2030. And so a lot of the, how do we get there? Buildings are a big part of that roadmap to bridge the gap. And benchmarking is one of the ways that these cities are looking to measure and manage the building energy use. So this is a list of cities that are participating in the benchmarking programs. Both Minneapolis and St. Paul participate, and St. Paul, as of this year, is also mandatory for reporting energy and water use in buildings over 100,000 square feet. So that reporting is giving a good view, and here you can see Minneapolis ranks pretty high in terms of the gray portion of the ranking being building policies as a component of the overall view for net zero and clean energy goals. There's a map that kind of shows the cities around the country that have adopted benchmarking, and a lot of that is based on Energy Star portfolio manager entering in utility data as a starting point to see, the consumption of energy by existing buildings. So if you don't know, where your building, how your building is using energy, and you want to learn more about energy management, Energy Star program portfolio manager from the Department of Energy and EPA are good resources. And likewise, this recently released report, February 2020, from the Department of Energy has innovations in sensor and controls for building energy management. If you haven't had a chance to look at that, I'd suggest taking a look. Also, when this deck is available, there's links in the notes area, at least for my section, getting to these resources as well. So as noted in the benchmarking programs, utility bills are a great starting point for existing structured data around energy use and consumption at the building level. However, it is often in a format that's not as visual and analytical, and there are many ways that you can get that into a more analytical view. A lot of utilities offer portals and programs for getting that data into Portfolio Energy Manager. Also, locally based Energy Print as a platform with weather normalized cost avoidance and tracking that can be used and also automatically feed into these portfolio manager and GRESB and ARC and LEAD and other tracking programs for compliance and measurement. Full disclosure, I am a business development consultant for Energy Print, so very familiar with that. But that's a good starting point. That's where the data exists right now for buildings. Going beyond that, where else can you get the data and start to manage? Submeters and data loggers can give you both revenue grade or non-revenue grade tracking with different degrees of cost. And then there are kind of stick-on non-revenue grade trackers that may or may not integrate with a building automation system. But it's a good way to start getting plug load level data around equipment draw. And then the energy management systems and building automation systems are really a great source that helps to tie this together and piece together from the thermostats, the HVAC lighting, if there's renewable with solar or other plug load management, fault diagnostics, all kind of rolled up into BAS systems, as well as energy information systems that bring in the utility data, weather, and trends. so one example of that. I had worked as, I'm a former employee and an investor in 75F, which is building automation solution, cloud-based IoT solution here in the Twin Cities. I wanted to highlight just a couple examples of, one, in this case, energy tracking. There's a unique view of getting kind of derived energy consumption without putting in submeters, really using the plate level data of draw from equipment and knowing when it's on or off and the duration, whether it's in stage 1, stage 2, and taking that and then deriving the consumption of at least the HVAC component of the load is kind of a poor man's way, but you know, a smart data way to get to tracking your HVAC load and also lighting. One other example from 75F is that there's a baked-in automated demand response capability, which in this chart shows the orange is the demand response signal coming into play, and up above you'll see the cooling in stage 1 and stage 2, light blue being stage 1, dark blue being stage 2, and you can see at 3 o'clock when this demand response comes from the grid, it goes to white, and basically shut that back and then pulled back onto only stage 1 cooling at that point. And as a result, there's a little bit of drift in the actual temperature versus the desired. Up until that point, it had been tracking to desired versus actual, and that's allowed to drift a bit at the point of the demand response. We'll see other examples, but that's one from my experience with 75F and installations we've done there. One other note is just the importance of consideration of upfront investment at the time of build. Smart technologies help. If you look at this model, it shows the 5% of total cost for life cycle of a building being that blue point at the tip, which is the design build construction piece, whereas the cost of ownership is 95% of the cost. So if you look at that over the lifetime and consider the maintenance and operations M&O benefits of smart technologies and energy savings, it makes a case for not value engineering out the smart technologies at the onset or build, and it also reinforces the importance of having retrofittable technologies that can be implemented in buildings, since the vast majority are existing buildings that are creating that energy draw. And then quickly want to touch on just some commercial real estate value perspective on energy management. This is from NTIC, guide on increasing energy efficiency, but it shows where commercial real estate leaders have ranked the value of some different technologies, including building management systems, asset management systems, but followed by energy management solutions having high value in the eyes of the CRE marketplace. And while we are focused on energy, I think most of you may be familiar with the 330-300 model made popular by JLL, that essentially says buildings spend an average of $3 per square foot per year on energy and utilities, $30 a square on rent and facility, and $300 a year on the people within that building. So well, we can see some great gains, as you saw in the market, with energy savings and cost avoidance. There's real value in the operational considerations and the commercial real estate value that comes with that, as well as even greater with the human factors. And I think that's that's accentuated and doubled now in the post-COVID era, when there's much more attention on safety, health, and wellness, and the human performance and the human factor, which trumps the rest of it. But so I'll get us back to energy, but I think we're all recognizing that there are some other benefits in the mix. One other report I'll cite here is the Stoke Financial Case for High Performance Buildings. And while it gets into a lot of resource management, energy, and such, it's really occupant experience, the environmental impact, resiliency, and kind of more of a holistic impact that high performance buildings can have, often hand in hand with these energy efficiency and smart technology implementations. So that wraps up my intro on the market section. I will hand it off to Lester Shen. Thank you for your time.
Thanks, Ben. I guess a brief introduction about CEE, Center for Energy Environment. We're a fee-for-service nonprofit centered in the Twin Cities. We have been around for over 35 years now. One of the things we do is deliver energy efficiency programs, a couple of utility programs that we provide that you might know about are the Home Energy Squad for the residential sector, one-stop lighting for the small commercial sector, and we also provide engineering services on the commercial side for things like recommissioning and continuous commissioning. And in addition to the program delivery, we also perform research projects. We get funding from utilities, not just in Minnesota, but around the country. State of Minnesota is another funding source for research projects, and we also perform research with funding from the US Department of Energy. Next, please. So we'll talk about intelligent buildings. Ben did a really nice introduction about that, or description of it. You could say maybe that it's kind of the application of the Internet of Things for commercial buildings. But when we talk about intelligent buildings, we're looking at using sensors and control technologies that make these buildings smart, connected, and allow for a higher degree of management and automation. And the beauty about intelligent buildings is we can integrate the variety of buildings systems together to create synergies as they communicate to one another. The advantages of intelligent buildings when applied to energy is that as energy becomes a larger and larger of more and more importance because of things like net zero buildings, SB 2030, carbon reduction goals, the operation of the building becomes really important. And this is where intelligent buildings can have a really big role. Next, please. Because of the building systems, we're dealing with lighting that deals with energy use, HVAC, heating, ventilation, and air conditioning in terms of conditioning the space. And then we have the networking ability that we can control and monitor the building, and then work on making the building not only efficient, but also creating a space that's comfortable for the occupants and supports productivity. So it's an important feature that ends up supporting that 300 level. Next, please. So when we talk about energy, why is energy becoming more and more important as we look at how we operate commercial buildings? Currently, as you know, we have an energy mix of fossil fuels and nuclear, and there's a move to become net zero or reduce the level of carbon. And so in our energy mix, we have coal and natural gas, which are plants that run pretty much 24/7. They provide base load. And then for times when we have greater need for power, we have these natural gas peaker plants. Now adding to the mix over, how many years, we have wind energy, especially in Minnesota. We have wind farms, and they're a big part of the grid, as we now have renewables, which are an intermittent energy source, because some days we don't have wind, and then times of the day we may get more wind, say in the evenings, than we do at other times of the day. And then we have solar, and on the grid side we have solar in terms of solar gardens or community solar. And then on the building side, we have rooftop solar. And that's generation that actually is behind the grid or behind the meter. In the United States, we're pretty lucky. We have reliable power. And so our utilities provide power to us. We know that when we want power and we want to turn on the TV, we can just turn on the switch. We don't have rolling brownouts, we don't have blackouts. You know, we're very lucky. We do have a strong mix of energy that provides us reliable power. Next, please. Oh, I'm sorry. I should have said next, please. I'm moving ahead. Okay, so this is a plot of the real-time load from yesterday, actually, in terms of what's been provided from MISO. Next, please. Now, as the mix is changing, the way power is being provided to us is affected, and this is what's known as a duck curve, which shows the energy demand, and this is for California. In 2013, you'll see the back of the duck, and the energy demand stays kind of level, and then towards the end of the day, it reaches a peak as people go home and turn on TV and start cooking and things. Since 2013, the amount of solar PV that's been entering the grid has increased, which means the energy demand, as we get kind of more rooftop solar, the energy demand starts to decrease as we have more solar. And so the power plants slowly have less and less power to provide during the day when we have sunlight. And then when people start going home, there's a large spike and the sun goes down. There's a large increase in the power, and the peak also rises. Next, please. So what are the implications of this? Well, the implications now is with this change in the energy demand, now during the day when there's a lot of solar, we may have overcapacity from the grid. And then towards the peak in the evening, now we need more generation. And so this is going to put stress on the grid. Next, please. And so this is where intelligent buildings can come in. Because as we operate the building, and given the way we can use these connected technologies, we can communicate not only with the systems in the building, but we can also see how they interact with the grid, and we can provide some flexibility in the demand. Okay, next, please. So basically what the idea would be is, instead of looking at how the power is generated, can we in the building flatten our demand curve? And in the same way that with the pandemic, we're flattening the curve by doing isolation so that we reduce the peak at the hospitals so that they have enough beds and things. The idea is, can we flatten the curve of our energy demand by efficiency, which reduces the entire curve, load shed, which can we reduce the amount of energy demand during peak times, and this would be called, this is kind of demand response. There's things like saver switches that we use for air conditioning, those sorts of things. So it's like, so reducing the peak. And then load shifting. Can we increase demand at a time when typically our demand is lower, and shift it so that we can use that power later? So maybe in the evenings or at night when there's a lot of wind energy, what if we consume the wind energy in the evening, store it in batteries, and then use that power during the peak? And finally, there's modulation. And are there ways within the building that we can modulate the power to make up for any quick shifts in how we get power, either from the grid or from our own generation? And an example of this is, we get solar energy from our PV, and then there's cloud cover, and all of a sudden we get nothing from the PVs, and how do we make up for that? Next, please. So that's kind of the idea of grid interactive efficient buildings, and it's called GAB. And this is something that right now the Department of Energy is very, very interested in, and there's a number of funding opportunities that are being issued by DOE to look more into GAB. And basically it's how do we take buildings, have them interact with the grid to create, through two-way communication, to create some demand flexibility so that we can not only have reliable, so that we can kind of support the reliable power generation that we have, as well as make sure that we support the occupant needs and ensure that all the occupants are happy and productive. Next, please. So this is kind of a schematic of a grid interactive energy efficient building, a GEB. And as you look at it, you can see that you have the end uses, you have the lighting, plug loads, there's the energy uses, the sensors, dynamic windows, a lot of the IoT devices that we talk about. I mean, this is basically your intelligent building. And then you have a BAS system that provides the management, the efficient operation, and you through the building, you can intelligently operate the building. In addition to those building systems, now we can also add generation in terms of rooftop PVs. We have storage in terms of battery storage and thermal mass, some thermal storage, and we have EV charging. And then the communication with the grid is through a smart meter. So we get two-way data going back and forth, as well as price signals. So that the communication from the grid in terms of when they need to communicate to the building to help make the demand more flexible is maybe through time of use pricing, time of use pricing and demand response, those sorts of things. Next, please. And so when we talk about demand flexibility, then with everything that's available to us in the intelligent building and with the generation that and storage that we have the ability to flatten our demand. And in a way, we make our demand more reliable to the grid. Next, please. So these are the characteristics that describe a grid interactive efficient building. They're efficient, they're connected, they are smart, IoT, and they provide demand flexibility. Next slide. So basically, we're defining an intelligent building. And when you look at it, here's our intelligent building at the center, the integrated building systems. And how it operates in terms of energy are the end uses, the efficient components, and then we add the communication and connection to the grid, which then makes the whole system a GAB. Next, please. And so basically what we're defining, basically what we're defining then is where do we come in? Well, big TC, we're dealing with intelligent buildings. AEE deals with energy efficiency and energy management on the behind the meter side. And in front of the meter, we have the grid piece, the power production, which again is part of AEE. And this is why it's great that we can all be here together and start a conversation. Next.
All right, is that my cue then? I guess I'll start. My name is John Reinhardt. I'm happy to be here. I'm the demand response technology lead from Great River Energy. And I appreciate the perspective that Lester and Ben and others were providing. I kind of going to bring it up to the utility level for a little bit and talk about how a utility might treat flexible loads in general, and that a grid interactive building kind of fits into that model in a really interesting and attractive way for a utility operator. I've been with Great River Energy for almost 4 years, and I've been working primarily on our demand response programs and evolving our systems to be a little bit more integrated. A little bit of an overview of the organization. Great River Energy, we're a generation and transmission electric cooperative. We serve 28 distribution cooperative members in the state of Minnesota, altogether about 1.7 million consumers. And there's a long history of a variety of different programs of demand response, DR, and load shifting. And some of these examples that Lester had just discussed were excellent. A bit of an overview of the portfolio of the controllable loads we have. A lot of the traditional load management or demand response is often associated with summer programs like the Save or Switch air conditioning program. We also have quite a few water heaters under control for peak load management, irrigation pumping systems that are interruptible, as well as some commercial and industrial operations that are interruptible or switch over to a local backup system. So with that fleet, we're able to do quite a lot with our summer peak load. About 14% of our peak can be reduced from a dispatch instruction or a fleet of dispatch instructions across our system. Winter programs are almost a bit more robust and significant in terms of peak reduction. We have a variety of dual fuel heating systems, heating storage systems, and water heaters. And a lot of our territory is residential. So a big portion of our dispatchable megawatts are in the residential area, but we still have a lot of year-round commercial industrial contracts for this interruption too. One of the biggest breadwinners, I think, of this organization, Great River Energy, is the daily off-peak load shifting. And I probably should have put that in even bigger font, because it's we're able to shift an enormous amount of energy to off-peak periods. And this is one of those examples where we're trying to take advantage of energy that we're trying to fill in the valley of our daily load shape. And that has an economic advantage because there's plenty of supply and not as much demand, so that energy can be produced cheaper. But there's also a good alignment with wind energy and renewable energy in the Midwest for wind power production. So it saves a lot of money for us as a cooperative. It saves the members money. It lowers the overall retail price of electricity, and it provides good alignment with green wind production. And I guess a little bit on the bottom here, I apologize, I might have cut one off there. We have a bit of bulk distributed energy resources. I'm going to use the word DER because distributed energy resources is a little hard to say, but this is a term that can include photovoltaic, which is PV, solar systems. It can be electric, batteries. It can be demand response. So anything that's a distributed resource that's not really a centralized power plant is what I would call a DER. We've got a few good commercial scale systems in our territory with some of our members, and quite a few that's pending. But I want to talk a little bit more about load management. Ben, if you would advance to the next slide, please. The load management technology that we're used to working with at the utility, there's a legacy radio frequency system, sort of a paging one-way system. And on the left is an overlay of our service territory and several of our transmitter towers and sort of a radio propagation coverage map. We've been using this system to communicate with all those different types of loads that I mentioned in the previous slide. the trends that we're seeing moving these days are really to foremost modernize the telecommunications systems with two-way feedback. When we send an instruction to cut out an air conditioner or a water heater, we wouldn't get a lot of feedback or confirmation that that actually occurred. And there could be many reasons why that didn't happen, technically speaking, or participations, or any kind of reasons like that. So two-way confirmation from that end point or from an interactive building is incredibly useful. Almost seems intuitive and obvious right now, but that's not always been there for these kinds of functions. Advanced metering infrastructure, or AMI, is definitely one of those telecommunications paths that can provide good two-way communication. It's an infrastructure that's used for smart metering. A lot of utilities are putting that out there for meter reading applications, for outage detection, and a lot of metering and billing functions anyway. That can be a really good backbone for communications, for load management, demand response, or interacting with a smart building. Wi-Fi is also becoming more popular, taking advantage of the internet service that's already there. Cellular communications, and a lot of this is enabled with a cloud-to-cloud integration. And I say that that's a way of alluding to there's a lot of software partnerships that enable all this to happen. You can do a lot of this with private networks and private development, but it really takes a coordinated effort of integrating systems. And that's one big challenge that I'm working on with Great River Energy, to bring a lot of different varieties of technology together. And some of these examples, I listed a few here for some of the trends and the loads themselves. And some of these may be embedded in such a smart building that was mentioned earlier. An interactive water heater, that really mostly refers to a water heater that can have two-way communication with the grid. It has some intelligent sensing about the temperature of the tank. It has some data logging that records the regular usage patterns, so we can anticipate when heavy usage is expected. Thermostat controllers, that's a really popular trend as well, where you can communicate directly with the thermostat rather than cycling an air conditioner with a relay bolted to the side of the house or the building and cycling the compressor. You can have access and maybe do some more elegant controls for temperature settings with that access to the thermostat directly. Electric vehicle charging, that's a big thing for Great River Energy, just being able to manage not only residential charging, or even on the side of the highway, the DC fast charging systems, but commercial buildings, we see an incredible opportunity there for fleets or people driving to work, charging their vehicle while they're on site and then driving home. That provides a really interesting opportunity for managed charging, or even two-way grid services if that battery can inject back into the grid. Building automation, I don't need to speak much about that. I think there's a lot of good content here already on building automation, but it sort of is a way of showing that all of these different individual devices can work in concert. And as a utility operator, we have these programs categorized and dispatched from our perspective, but a lot of these different varieties of loads may be integrated in concert behind that building management or the building automation. And us as the utility may see that building as one packaged load that can provide flexible load, it can provide grid services, and perhaps we may not even see behind the front door of what are the suites of loads that are controlled there. So there's a lot of different levels and layers of abstraction that you can think about this, that the utility likes to know what each load can do, but that's sort of the same model that a building may be able to do micromanagement of various loads behind that meter. Next slide, please. Some of the grid services that a utility might need. Traditional program design, again, is for managing that peak period, that peak usage, and shifting some of that energy to lower cost times. flattening the curve is actually a really interesting concept. And I think that it is sometimes beneficial to maintain and manage that load profile, especially when considering if peak usage at a building is in a congested area of a circuit, a distribution circuit, and you're worried about overloading the substation, the transformer, the electric lines. You need to maintain and use those power lines and infrastructure as well as you can. So a flat load profile may help prolong and delay any capital upgrades. Now at the grid level, sometimes what we're seeing is that there is a huge oversupply of wind generation, and there sometimes isn't enough load on the system to consume that wind energy. And in fact, earlier this week, there was a little bit of a news flash where there was so much wind energy in the Midwest and in southern Minnesota that I guess in general in the Midwest, there was so much wind energy that prices were zero and even went negative. And that's sort of an odd concept to think about, that the market, the energy market, and there's a wholesale market called MISO that manages the transactions of energy. If there's a negative price signal, what that means is that there's so much energy that they would be willing to pay people to turn load on because there's all of this renewable energy available to take up. And if there isn't enough load, then a lot of that good, clean resource out in the plains gets wasted and curtailed. And so there's sort of there's a dynamic there where we used to have generation systems like gas, coal, nuclear that were built to follow the load pattern. And now with our intermittent renewables changing, it's beneficial to have the load follow the generation. So I kind of, I throw that in there just as a balance to think about that a static target is not always going to be the most flexible thing. And it's mentioned earlier by Lester that flexibility is key to be able to change and manage these various objectives. I think the third bullet point is just to remind that if you think about the building as a power plant, it is sort of a virtual power plant if it can provide grid services. We might ask a gas power plant or a coal power plant to turn up or turn down to meet the needs of the load. Well, that's the same thing that a load center, like a smart building, might be asked to do to increase or decrease its power to provide good grid services. And there are organized wholesale markets that would provide an economic incentive to have a building react to those kinds of things. We cannot possibly micromanage all those different loads that are providing those services. So again, we might see that building as really just one resource, and we would ask it to provide some services. And the building management system would decide, what can I do with my water heaters, my air conditioners, my HVAC systems, my blinds, and all those other things to provide that service to the grid. We don't need to know as a utility every little item that's doing that service, as long as the instruction is followed. So on to the next slide, I think I want to just mention, I'm keen on this topic of grouping and allocating for dispatch instructions. So I'm going to keep on that for my last few slides here. These are some active research questions that a DER, and again, that's a distributed energy resource, which is a combination of plug loads of electric vehicles, of demand response, but also PV systems on the rooftops. And I wanted to mention that even for a building there where PV may be installed on the rooftop, I think that is sometimes an economical choice. And sometimes if the grid is over generating the wind, like in my previous example, it's economical to consume energy too, but I think it's just good to have total flexibility and balance to take advantage of it hour by hour. So the benefits and limitations of grouping strategies, I've drawn some circles across the fictitious grid where you've got different buildings, and maybe you'd want to group these according to different categories or substations, different types of loads or segments of the network. So I'm not going to list each one of these out loud, but these are some of the topics that with all of these different load types coming on here, it's important for safety. For example, if there's an island, there's a circle in the upper right corner there called an island. So suppose there was an outage on that transmission or that distribution line, a tree fell on it, and the circuit needed to be isolated so the crews could be dispatched out there to repair it. Well, there needs to be good coordination and communication to the smart building that may have that PV system, wants to self-generate and keep power going. But if it's injecting power back onto the system, that can create a safety hazard for crews that are repairing those lines. So there's a lot of coordination that's needed with all these systems. And I want to just lay out a few of those examples just one at a time. In the next slide, I just maybe the most intuitive way you would group resources is by geography or topology. So I say grid topology, meaning I want to isolate and know what are the kinds of resources for demand response or PV that are at a certain substation or feeder for responding to an outage or for doing some distribution management. The different zones or the different cooperative zones, in our case, it's important to be able to isolate and send in unique instruction for each of those. But also for pricing zones, this goes back to the wholesale price perspective that costs can fluctuate based on the locational price. And it's good to be able to move those in concert, one up, one down, to respond to those prices, in addition to generation profiles from wind and solar. The next slide talks a little bit about the different characteristics of the load itself. And these are the things that you might consider within a single building. You've got all these different load types, and that was a really elegant slide earlier that showed the picture of all of those different things. In addition to load types, so an age of a building, that might have something to do with the amount, like the leakiness of its HVAC system, and the size of the company, the size of the building has some impacts that might make you decide the decisions of it. Now, severity and priority is another one I think about, where it's maybe more critical to maintain a freezer or refrigerator power so you don't have food spoiling in a pantry or cafeteria, whereas a water heater may have more resilience to an interruption because it's got a certain number of gallons of hot water it can withstand. Some of the other characteristics on the right are a bit more technical on what distribution operator would want for managing voltage or power factor of the load itself. So these are things that you could, again, think about the building wanting to manage within itself, but these are also things that the utility would want to see from its suite of demand response resources or PVDERs. The last example, and then I kind of want to wrap up with maybe a bit of a silly example, but this one here is a bit dynamics on like the time response. And what I'm showing is a graph from one load management event that Great River Energy had dispatched in recent months. And this was an example where you may have, and I'm showing several different days overlaid over a 24-hour period. The point of this graph is to show that when load is curtailed, and some of this load was curtailed due to water heaters or air conditioning systems, when that load comes back on, it may actually bring back on more energy than in that instant that it's recharged. And the pink curve shows what that load would have looked like otherwise. And if that load isn't restored in a graceful manner, you get a little bit of an overshoot, as an example, from some thermal loads. So you might want to know how much it's going to overshoot as a utility operator. I might want to know that, and how much time is it going to take before it settles back in. That might help to, for a building management system, if you've got a variety of different loads with these different characteristics, and you're responding to an instruction from the utility, how you might stagger or stage these things in to smooth out your building's response, to manage your local peaks and provide good grid services. So the final slide, I guess, is just to kind of wrap together all of these combinations that it's a little bit of a dizzying set of options, but we think that there might be value in having all of these options at least characterized to some extent. And there's probably a lot more categories than this. Knowing, optionality and flexibility is key here. I think that's the main message. And knowing the different classifications you can select upon helps you achieve all these different grid functions. And the example I have in the lower right, I kind of think of it as a classroom of kids, and different, a teacher might have a game or something which says that if you've got brown hair and blue eyes, you're going to go to math class now. And if you're sitting in a red square and you were born in the summer, well, you get to go to recess. And that's kind of a way of selecting different classifications out of a whole suite of possible, children in this case, but different assets for the grid or for your building. Having those different classifications to select upon and call upon gives you a lot of good flexibility. So I just wanted to make that point about just optimizing all these different characteristics and parameters. And that's the last slide I had. I don't know if there'll be time for questions at the end, I think. Is that right, Ben?
Yeah, we should have time for questions. If you have questions during the presentation, feel free to use the chat function to submit those, and we'll work through those and then handle vocal time permitting. Thanks, John. Appreciate your time.
Thank you.
All right, can you press on to the next slide, please? All right, so I just want to say thanks to Brad, Peter, Ben, Dr. Shen, John, as well as both Big TC and AEE for sponsoring the event. Really appreciate the opportunity to speak here. A little bit about Parallel Technologies. So simply stated, what we do is we make buildings smarter. So we're a Minnesota-based contractor with a national footprint. We have offices in both Eden Prairie and Omaha, Nebraska. We've been in business for nearly 40 years. We've witnessed firsthand the analog to digital transformation in communications. We provide solutions in communications, security, safety, automation, and reliability. And we deploy solutions based almost entirely and exclusively on modern network communication systems. Next slide, please. So to start off, summarizing the conversation that I've heard this far, and just showing a little bit of a different point of view on this topic. What I'm hearing is that smart grids need smart buildings. The grid provides a constant power profile, so we need to engineer some flexibility into the building. We need to make buildings smarter. And this is really new information for a lot of small, medium business owners. So Parallel is a small, medium business. I am aware of the regulatory changes around sustainability, 2030, but as a business, Parallel is not making decisions that are influenced by those regulatory requirements out there. So given that gap in knowledge, how does a business owner make decisions around intelligence in buildings? Well, we need to talk about the needs of the business rather than the needs of the building. Next slide, please. So as a business owner, I want to ask the question, should I convert my dumb building to a smart building? And the answer is always only if a business case exists. I want to take a look at 4 factors here which influence business decisions and how intelligent building infrastructure plays into each. Compliance and code, corporate goals, risk reduction, and corporate profits. Next slide, please. So compliance and code. So why do I want a smart building? Well, one reason is because I'm forced to. Compliance requirements are really powerful tools that we can use. Ben touched a little bit on sustainable building codes in Minnesota. So the state is going to begin to tackle this issue by attaching requirements to state funding mechanisms. Government, K-12, public schools, higher education. Each of these organizations are going to need to comply with a mix of sustainable practices, which may include things like on-site renewable energy generation through PV and energy efficiency techniques. Similarly to that, Parallel right now is deploying a lot of public safety data systems. These systems don't directly benefit the operation of the business. it's not saving money, things like that, but it is required by code, so we install it. It's a really powerful method by which to include technology in buildings. And just a side note here, as the A&E community is well aware, we generally don't see code well enforced day one. We ease the businesses into the process. So the stuff that we're doing in public safety that's really a hot topic in the industry today has been compliant for several years already. So we do see a period of a slower period of adoption following codes. Next slide, please. Another business case that I'd like to talk about is reducing risk through technology that's both reliable and proven. So today, in the time of the COVIDs, we are trying to figure out how to eliminate and reduce exposure. So one of the common questions that I'm getting these days really is how do I leverage smart cameras to detect elevated body temperatures? So we do a lot of security system work, and we do a lot of camera work, and analytics are built into those cameras. And so people are trying to find ways in which technology can help reduce risk inside the building. What you see up here, filtration, ventilation, exhaust, temperature and humidification, sterilization, all of these recommendations come directly from ASHRAE's position paper on the topic. And each of these are an opportunity to install intelligent components inside the building. So for each of these, filtration, ventilation, exhaust, sterilization with the UVGI stuff, and adjusting temperature and humidity, each of these requires some level of building intelligence, whether it's communications infrastructure, intelligent sensing, IoT sensors, occupancy scheduling, or HVAC controls. Next slide, please. Another way in which we align business needs with intelligent infrastructure when we go to deploy projects is by taking a look at the corporate goals of the organization. So we want to spend capital, or the business wants to spend capital to support their charter statement. Over on the right-hand side is the charter statement of the Big TC group. So often one of the first things that I do after an introduction to a new client is I go out and I read their corporate messaging. So who are they? What's important to them? Is my potential project with them supported by their business goals? Do I have a good chance of this project succeeding? Over on the left-hand side are a bunch of terms that I would start looking for in charter statements if I'm looking for organizations that want to participate in efficient communications between grids and buildings. So green, reduction, conservation, sustainability, all of these are the terms that I'd be looking for. Next slide, please. Another way that the business takes a look at lowering their costs is with utility rebates. So we've done a number of projects on data centers, specifically on data center generators and peak shaving. So we worked with local utility cooperatives on their programs. What we're finding is that businesses that rely on the generator to support either their remote or their local workforce still need to have some sort of power generation to provide uninterruptible, reliable power inside the building to support all of the communications and technology that support their workforce, whether they're local or remote. We also have found that green can be expensive. So when we go to deploy a data center generator with EPA Tier 3 emission standards, there's a lot of extra cost involved on the generator itself. The generators are more complicated pieces of equipment, and they have to be installed in a little bit of a different way than traditional equipment. There might be a minimum power output required specified by the utility. So small data centers with small 20, 30 kW gensets might not be able to apply for these programs. And we also need to talk to our customers about reliability as the business driver and not the utility rebate. So we're deploying these generators in order to support operations of the business, and the utility rebate is sort of an extra. Tier 3 EPA certified generators are a more complicated piece of equipment, and as such may be a little less reliable. There's DEF, which is the diesel fuel that has to be used in order to support those urea conversions. We also find that there are installation and conversion concerns with generators. We deployed, we built a data center down in the southern half of the Twin Cities years ago, and then did a conversion project to a peak shaving generator with them maybe a decade later. And the generator was installed in such a way that it was very close to the building to lower the cost of feeders when installed. But this raises a lot of havoc with installation when you're talking about EPA Tier 3 certification. So the exhaust stack on the generator needed to be increased so that it was over the building, or we had to move the location of the generator on site. Those are expensive propositions, both in terms of money and time down on the data center or the data center generator. And then we need to take a look at return on investment in those projects. How many years out are we going to see that crossover from CapEx to OpEx? And then finally, smart requirements on programs like this are all the things that both Dr. Shen and John were talking about with the smart communications infrastructure, talking between the grid and the building. Next slide, please. So we can also serve business goals through cost reduction. And one of the ways that we can do that is by measuring and analyzing the operations of the building. So we do a lot of building automation systems over at Parallel Technologies. We're a building automation contractor. There are some guidelines that we take a look at for successful projects. And these include things that I have here on this slide, like avoiding antiquated technologies. There's a lot of risk in those things. So serial communications, 2 and 4 wire, they're expensive to troubleshoot, they're expensive to maintain. We like to deploy on modern networks for scalable, secure solutions. We leverage existing infrastructure that can communicate across different solutions whenever possible. One example of this might be taking occupancy sensing off of people counting on cameras and pushing that over to the building automation system to control ventilation and CO. Utility rebates for lighting and HVAC updates are a powerful tool when we deploy to the client. So CEE, as Dr. Shin mentioned earlier, has a couple of programs. Their one-stop programs are great. I'd invite anybody to take a look at those and contact Dr. Shin. And then finally, we want to analyze that data for savings. So we have a project going on right now down in the south half of the Twin Cities where we are replacing over 200 VAV controllers and several plant controllers. The equipment on site is a couple decades old at this point, and what we've found is that there are really inefficient operations in the building that have really inched up over time. So dampers on these VAV boxes have sometimes been fixed in their position. People will put a screw in them. They might remove a linkage on the damper. They might break the actuator so that it doesn't work. We've seen all of these things in this building. And then what does the demand response look like? So can we analyze the information to figure out if the equipment is broken? Absolutely we can. We can take a look and figure out which of these pieces of equipment are operating at peak performance. Smart requirements for systems like this are obviously the data itself. We want to be pushing data between security systems, automation systems, all the different types of systems that are smart inside of the building. We need communications infrastructure, and intelligent IoT sensing is really key to a lot of this. Next slide. Shifting gears just slightly here. If smart buildings need smart infrastructure, and the solutions that we deploy are going to operate for years to come, we need to start making some technology decisions now. The graph that I'm showing here is different components inside the building in the life cycle in years. So the building structure itself is the base of what we're talking about. That's a 100-plus-year-old structure in many cases. But the utilities, the mechanical, electric, all the structured cabling, all of those have a life cycle refresh that we should be taking a look at. We need to understand that during infrastructure replacement, renovations, and building updates, there's opportunity to introduce solutions that really support future building standards and the future building needs. We need to deploy technology during the opportunities that we have. And we need to deploy solutions that are going to comply with future requirements. So budget solutions that you might get from a contractor today, the lowest cost isn't necessarily the best cost. Back to the slide that Ben showed earlier with the funnel and CapEx versus OpEx. Next slide. 2030, it's 10 years away. Today, we're doing a lot of planning. We're deploying basic building blocks. We don't want to get to 2030 and try and have to figure out how to do all this. We don't want to have to try and convert a dumb building to a smart building in one project. We want to make a process out of this. We want to have a roadmap to get our clients from one place where they are right now to a smart building in the future. We know that every building, well, really every business is different. So we look for the commonality in the solutions that we deploy. We look for communications. We look for efficiency projects. We look for compliance projects. These are all things that pretty much every business can agree are important to their corporate goals. And then building automation systems developed with open communication standards, with the ability to comply with cybersecurity requirements. One of the questions that we're often asked these days is, what does our cybersecurity policy look like? And what does the cybersecurity of the solutions we deploy look like? So we need to federate the data in the building into the cloud to collaborate with those systems in order to get to that smart building in the future. Next slide, please. Ben threw up this slide earlier in the set, and I just want to roll back to it a little bit. So if we're talking about spending money on infrastructure inside the building, you need to take a look at where you can most effectively make use of those dollars. And obviously, the holy grail is to get over to the 300 and the productivity of the people inside the building. But where we as a contractor play mostly is in the 3 and the 30. I think the 3, has received a lot of looks over the years. The 30, the operations of the building, that's generally where we focus most of our attention. It's on those systems that operate, that can replace the human component that's not as reliable as technology. That's really where we find efficiency inside the buildings, or in the operations of the building. Next slide, please. So lastly, some strategies for deploying smart infrastructure. First and foremost, we always have to align with the business goals of the company. If we don't do that, we don't have a chance of our project succeeding. We need to specify intelligent infrastructure. We need minimum standards enforced through specifications, and we do not want to allow antiquated technology inside the building. That lower cost really is going to come back to bite us in the end. We want to require products with open standards that communicate with each other. We want to base all of our systems on IP network communications so that we can not only use the modern tools, but we can use the modern tools skill sets of the people coming out of college. We also want to require qualified contractors, look for contractors with a history of success in both the solutions and the products. And we want to protect the business goals by not value engineering out intelligence in these systems. Last slide here. We need to educate business owners if we want projects to succeed. So the message earlier from Ben through Dr. Shen and into John really was that the grid is providing a constant power profile. So we really want to engineer flexibility into our buildings. We want to make our buildings smarter to interact with the grid. And this is new information. This really is new information for small, medium business owners. There's an opportunity to go talk to them, to educate them, and bring them up to speed. Thank you.
Okay, thank you, Matt. Thanks, John. Dr. Shen, appreciate you all contributing here. From a timing standpoint, we've got a few minutes remaining. We went a little long in timing, but Brad, can you advise if we've seen anything come in from chat and Q&A?
Yeah, this was a great presentation, really good content. Thank you all for organizing this, and there's good feedback coming through the chat. Ben, you had mentioned using plate level information along with runtime info to calculate energy use. Is the plate level equal to nameplate level?
Yeah, right. So that's the consumption for the equipment. The nameplate level data captured, entered into the system. The example I used was 75F has that as a built-in capability where if you it takes a bit of work to go around and gather that, assuming you can read the nameplates and pull that in. But yes, it's pulling the power, at least the out of the box or new equipment draw levels off the nameplates.
All right. My colleague Zach Pointer asked, are electric utilities looking at hydrogen storage at wind turbines as an energy storage option? It's a question for John.
Yeah, I will say we're not personally looking at hydrogen storage. There's just an incredible amount of research and development on different types of storage. Earlier this month, Great River Energy announced a new demonstration project we're launching with a startup company called Form Energy, and this is a long duration storage project that's meant to be able to hold energy for 150 hours, which is far longer than a lot of traditional lithium-ion batteries, which are sometimes limited to a 4-hour operation. The actual technology itself is a little bit of a trade secret that we don't even know. I think it's there's some discussion about it being sort of like a flow battery style, but it's a kind of a proprietary patented technology from Form Energy. That's one of the biggest energy storage mediums that we're investigating, and we'll have this demonstration project operational in 2023.
Thank you. John, another question for you. This is from Tom Smirtnick, and he gave you some multiple choice options you can answer with. For ease of asking the question, I'm just going to ask you which of, what's the biggest and most critical near-term issue that utilities face around distributed energy resources?
Yeah, I see the options, and it's a really great discussion piece.
Yeah.
I guess I would say, the pricing models to interact with DER owners is probably the biggest challenge. I think there's a lot of tricky challenges with net metering rules, with DER owners, and wanting to make sure that everyone gets a fair stake and a fair reward for their effort to support the grid. It can be challenging to strike that balance and make sure that we're maintaining a safe and reliable wires in delivering power, but also receiving power that an end user might be generating. And so, that's probably the biggest trick across the country, is developing a good rate structure that can support that fairly and equitably.
All right, I had one more that just came in here from Jack Powley. Does Great River Energy feel that storage solutions or increased transmission ability provide greater flexibility in grid operations?
I would definitely say so. Transmission capability, absolutely. It's a key component of some of our. There's a project called CapEx 2020, and there's a revamp of it. What it really is a regional organization of various utilities trying to bundle investment for putting transmission wires in the right place to be able to access plentiful renewables. That's of huge importance to be able to, deliver power where it's needed, but bring it in from different locations than it's geographically not normally located at. And storage solutions, absolutely. We consider our demand response to be a kind of a virtual storage. The water heater is something we often call a battery in the basement, because it provides a big community storage, in a way where you've got a lot of different assets that can start and stop and provide those services like a battery.
All right, any last words from any of our presenters today? If not, thanks everybody for joining. Thank you for your time. Thank you for, once again, for all our presenters. And to our AEE friends, if anybody is interested in getting on the Big TC mailing list, you can respond to the invite you received for this meeting. That Big TC at Gmail address will get you signed up so you're on invites for future meetings. But thanks again for everybody. We're at time. We're going to wrap this up, and hopefully I will be able to figure out how to send the recording out to everybody. And Ben said he will share these slides for a number of people in chat who are interested in being able to get. So thanks everybody. Have a great holiday weekend.
Great. Thank you. Likewise.
Great.
Thank you, guys.
Thank you, everyone.
Take care.